Welcome. This session we will talk about how to find maximum shear force at a section in a simply supported beam or girder AB having 40 meter span when a shorter UDL of span 5 meters is traveling from left to right. The UDL value is 10 kilonewton per meter. Okay, right. So we are interested in the shear force. So we need to plot ILD for shear force at a section. Okay, let us plot ILD for shear force at a section. So we draw a reference line, then drop this section onto the reference line. Now plot ILD for shear force as we have learnt in previous lectures. So this is negative ordinate, this will be the positive ordinate, and this will be joined to 0 at the other end. Okay, so this is denoting positive shear force, negative shear force. So this is ILD for shear force at a section, shear force at C. And these maximum ordinate values are nothing but it is 10 divided by 40, which is 0.25. This BC span is 30 divided by total span is 40. So this ordinate works out to 0.75. Right. So once you draw the very basic information, that is ILD for shear force at a section, then next is to get maximum shear force at C, how to position this shorter UDL as it travels from A to B. Right. So as you see, the shear force is now spread across the negative as well as positive. So you will have maximum negative shear force as well as maximum positive shear force. So though we know by visualization, as you can see it here, maximum positive shear force is going to be the maximum shear force. So we will see that even we calculate negative shear force, and we will see that among these two values the maximum positive is the higher value among these two, right? So first let us calculate maximum negative shear force. Okay, so we calculate maximum negative shear force first. So how to position this UDL? So I place UDL like this. (10 kilonewton per meter). So this is the ordinate and this is the area occupied by the UDL. So if you want shear force value from earlier lectures, you know that when there is UDL on ILD, so how to use ILD when there is a UDL? So it is simply area occupied by the UDL multiplied by the load value. So area here is, it is trapezoidal area, and this is 0.125 is the ordinate here, and this ordinate here is 0.25. So if you work out from similar triangles, you will get 0.125. So it is 0.125 plus 0.25 divided by 2 multiplied by the distance between these two parallel sides is 5, and this is the area of trapezoid multiplied by the load value is 10. So this is nothing but 9.375 kilonewtons. So this is maximum possible negative shear force at section C. Right, now as load moves further, it is going to occupy a different position. So now let us place the UDL in this manner. So this is now the load position. As I said, you have to make the load to occupy maximum area. So this is the maximum possible area that it can occupy. So as you go further, the ordinates are going to be lesser. So lesser area, this works out to be lesser area. So this is the maximum possible area. So now work out for maximum shear force at C. Okay. So similar formula holds good again. The area multiplied by the load value. Area is again the two parallel sides. So this ordinate here works out to be 0.625 from similar triangles again. So the two parallel sides are, one is 0.75 plus 0.625 by 2 multiplied by the distance between those two parallel sides is 5 meters. That is the span of the UDL multiplied by the load value is 10. So this will work out to 34.375 kilonewtons. So this is maximum positive shear force. So you can see now, as we discussed earlier, maximum positive shear is going to be maximum among these two values. So you have to report your answer. Maximum shear force at section C is equal to 34.375 kilonewtons. So is this maximum negative shear force, is this required to be worked out? If you say, if you can guess exactly that yes, this positive shear force is going to be the maximum value, then there is no need. When your question is to find maximum negative shear force, then you need this to be worked out. Otherwise, if it is just to work out maximum shear force at a section, you can directly work out by virtue of your intuition, or by looking at it, or physical observation of this diagram. So this area is always more than this area because the ordinates are higher in this case. So hence you can work out directly this value. Okay, right. Thank you.